All right, Algebra 3, folks, it's time for the Module 3 practice test. So I'm going to work this. You can check in on any problems you're struggling with and see how I did it. Okay, let's go through this. Number 1, what is the quotient when we divide 91y to the third plus 21y squared minus 35y by 7y? Okay, so let's set this up as a long division. 91y to the third plus 21y squared minus 35y. All right, so how many times does 7y go into 91y to the third? Well, 7 goes into 91 13 times, and y goes into the y third, y to the y squared times. So when I divide y out of it, I get y squared, right? Y squared times y will give us y to the third. 13 times 7 to give us 91. So multiplying that, it's 91 y to the third. So all of that goes away. Got to bring down the 21y squared. How many times did I go into it? 3. 7 goes into 21, 3. And y goes into y squared, y times. So when I multiply that, 21y squared, when we subtract that, we have nothing. So bring down the negative 35y, and that will go into that negative 5 times. So negative 5 times 7y is negative 35y. So this is our answer, 13y squared plus 3y, right, minus 5. There we go. All right, now I want to know what is the quotient when we divide this polynomial by x plus 3. So let's set that up. And we'll do 2x squared plus 12x plus 18. Okay, x into 2x squared. That goes in there 2x times. So 2x times x squared is 2x squared. 2x times 3 is 6x. Subtract that. That gives us nothing. This leaves 6x. 12x minus 6x. And then we bring down this 18. So how many times does x go into 6x? It goes 6 times. So 6 times x, 6x. 6 times 3 is 18. Subtract that. Remainder of 0. So 2x plus 6 is our answer when we divide the polynomial by x plus 3. All right, using synthetic division. What is the quotient when we divide this polynomial by x minus 2? So for synthetic division, we set that equal to 0. And when we add 2, so that's x equals 2. So that's what we're using for synthetic division is our 2. And then we use, remember, we're going to use the coefficients of each term. So this is the coefficient of the x to the third term. That's x to the third. So we have to put the coefficient of the x squared next. Remember, we go in descending order. We start with the largest. What is the coefficient of the x squared? Apparently it's 0 because we do not have it shown in the polynomial. And then the coefficient of the x. And then finally, we have the constant. So remember, synthetic division, you bring the first one down. 3. Now we multiply and add. 2 times 3, 6. Add that to 0. 2 times 6 is 12. Add that to 4. And 2 times 16 is 32. Remainder of 0. So our answer then is this would be 3x squared. It's 1 less than what we started with. It started with x to the third, so this would be squared plus 6x plus 16. So this one. Remainder of 0. Onward and downward. No, onward. What's the remainder? This one know what the remainder is when we divide all of this by x plus 2. So I'm going to do synthetic division again. If this is x plus 2, I'm going to use minus 2 for my synthetic division. Coefficients, starting with the fourth. So coefficients 3. For x to the third, it's 2. For x to the second, it's negative 1. For x, it's 2. And then finally the constant. Okay, bring the first one down. 3 times 2 is negative 6. Add that to 2 is negative 4. Negative 2 times negative 4 is 8. Add that to a negative 1. Negative 2 times 7 is negative 14. Add that, negative 12. Negative 2 times negative 12 is a positive 24. Well, look at there. Remainder is 0. So that is one of the factors of this polynomial. It's one of the zeros. It'll cross the x-axis at negative 2. According to the fundamental theorem of algebra, how many zeros is the function f of x equals 15x to the 23rd plus 41x to the 19th plus 13x to the 5th minus 10? Well, all I care about is the biggest exponent, which is 23. So this has 23 zeros. There are 23 zeros to that equation. I'm not going to figure what they are. It doesn't ask what they are. I just want to know how many. This one asks me what they are. What are the zeros of the polynomial function x to the third minus 2x squared minus 24x? Okay, so apparently, looking at our choices, it's going to have something. 0 is going to be one of them for sure, because every term has an x in it. And if we substitute 0 in for x, 0 minus 0 minus 0, and that is going to be one of these zeros. So 0 for sure is one of our solutions. But the question is now, is it a negative 4 or positive 4, or is it negative 6 or positive 6? Well, we know the first coefficient's a 1, and this is 24. So all the possible is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. 6 times 4, 3 times 8, plus or minus 2 times 12, and then plus or minus 24. So there's a lot of choices. There's 16 different possible zeros. We know using Descartes' rule, it's positive, negative. There's only one sign change. So there's only one positive real root. So that rules out this one already, because 4 and 6 can't both be a root. If we change and we put negative x into there, negative x to the third becomes a negative x. This one stays the same. And put a negative in there, that becomes a positive 24 x. So f of negative x, substituting negative x in there, says negative, negative, positive, one sign change. So they can't both be negative, because there's not two negative roots either. So we know it's either 4 and negative 6 or negative 4 and positive 6. So we were able to rule some out just by using Descartes' rule of signs. All right, so let's use synthetic division. And let's check negative 6. Okay, x to the third, coefficient's 1. X to the squared is negative 2. X is negative 24. And then a constant 0 out here. Bring the first one down. 1. 1 times negative 6. Add those together, negative 8. This is positive 48. So that's 24. And then when we multiply that, you're going to have a great big remainder. Negative 6 does not go in there equal, right? We do not have a remainder of 0. It's not going to be negative 6. Let's try positive 6, the second one. Same coefficients, 1, negative 2, negative 24, and 0 here. 6. Oh, bring the first one down. 6 times 1 is 6. So this is positive 4. 4 times 6 is 24. 0. Okay, 6 worked. There's no remainder. No remainder at all. So 6 is definitely one of them. We're going to check double negative 4 just to make sure. Maybe we ruled something out by mistake we shouldn't have. Okay, bring the first one down. 1. 1 times negative 4 is negative 4. Negative 6. Multiply those together. Positive 24. Yeah, all of those work out. remainder 0. So negative 4 and 6 are the other two zeros. All right, what are the possible rational zeros of f of x equal x to the fourth plus 2x to the third minus 3x squared minus 4x minus 12? So remember, we take the coefficient of the first one and we put it at the bottom, right? That'd be our q, and our p is all the possible factors of negative 12. So this is just a 1, so that makes it easy. So all we care about is the factors of 12. Well, 1 and 12, 2 and 6, 3 times 4, and that's it. That's the only numbers that could be multiplied together to be 12. 1 times 12, 2 times 6, 3 times 4. And so all of those are plus or minus, all of those. Let's see. This has plus or minus everything, but no, like 5 is not a possible root of that. This one, 1, 2, 3, 4, 6, 12, 1, 2, 3, 4, 6, 12, that matches it, but that's only positive. It could be negative. Every one of those is a plus or minus. 1, 2, 3, 4, 6, 12. Here it is, plus or minus 1, 2, 3, 4, 6, or 12 are the possible. There's 12 possible rational zeros. Not this one either, because that has 5 and 8 and some other numbers are not included. So, what are the possible numbers of positive, negative, and complex zeros for this polynomial? All right, so how many sign changes are there? Starts with a negative, 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 negative. Okay, so there's only one sign change. That means there's one positive root. One positive natural real root. So this is positive 2 or 0, positive 1, positive 3 or 1, positive 4 or 2. This one just has 1, but let's double check our negative. When we substitute negative x in there, so negative 3 times negative x to the fourth power simplifies to be just x to the fourth power. So that doesn't change. Negative x to the third power is negative x to the third power. So that will change that. 5x to the third. If we substitute negative x there, negative x squared becomes positive x. So it's still minus x squared. Negative x times 8, negative 8, it makes it a positive 24x, and then plus 4. So how many sign changes do we have here? 1, 2, 3, and then those are the same. So that means negative is 3 or 1. 3 or 1. 1. We know there's 4 total. Right? So if there's 1 positive and 3 negative, that means there's 0. If there's 1 positive and 1 negative, that means there's 2. So that is the right answer. Complex is either 2 or 0. It basically depends on negative. There's definitely 1 positive. The negative is either going to be 3 or 1. So the complex is either going to be 2 or 0, depending on how many negative roots there are. All right, which of the following represents the zeros of f of x equals 6x to the third minus 29x squared minus 6x plus 5? Okay, so we know that there are, let's see, 5 is only 1 times 5. That's the only possible numbers on top of the fraction. 6 is 1, 2, 3, and 6. That's the possible numbers. This is all plus or minus, all right? So if we look at that, plus or minus 1 over 1, which is 1, plus or minus 5 over 1, which is 5, plus or minus 1 over 2, plus or minus 5 over 2. Okay, and then we have plus or minus 1 over 3, and plus or minus 5 over 3, and plus or minus 1 over 6, and 5 over 6. So there's all the different possible real roots. 1, 2, 3, 4, 5, 6, 7, 8. So there's 16 of them, considering the positives and the minus. Now this has narrowed the choices down for us. It's either 5 or negative 5. It's either 1/3 or negative 1/3. It's either 1/2 or negative 1/2. So it has narrowed the choices down for us. What do we know here? Positive, negative, positive. So there are 2 or 0 positive roots. 2 or 0. This has 2. This has 2. This has 2. This has all 3. All 3 cannot be because it's either 2 or 0. All right, so negative roots, if we put in negative x to the negative x there and we make it to the third, that's going to be a negative. This is going to stay a negative. That's going to become a positive, and that's going to be a positive. So there's one sign change. So there's only one negative root. One negative, one negative, one negative. Okay, so we've got it narrowed down to those 3. So we can use synthetic division. That would be pretty simple. Let's check this negative 5. And this is 6x to the third, negative 29x to the squared, negative 6, and 5. Okay, this comes down. This is negative 30, right? Negative 5 times 6. So that's negative 59. Now we've got this great big number. We'll multiply together 295. Add that to the negative 6, 289. Okay, this is definitely has a huge, because this is over 1,000, right? So this has a big remainder. It's not going to be negative 5. That doesn't work at all. So this one's ruled out. So it's either going to be one of these two. Let's check that 5 first, which we're pretty sure that works because that's the only choices left. They're saving us a lot of work by giving us choices, not making us come up from scratch here. Okay, so the 6 comes down. 6 times 5 is 30. Makes that negative 1. So that's negative 5. 5 times negative 1. Add those together is negative 11. 5 times negative 11. Something's wrong there. We didn't end up with a remainder of 0 on that one either. Did I mess something up? 6, negative 29, negative 6, and 5. 6, 30 is 1. 1 times 5 is negative 5. Negative 11. No, that's definitely right. We have a negative 50 as a remainder. I don't show 5 as a root either. All right, let's look at graphing this. Okay, so when we look at the graph, we see there's a root at 5. There's one at 1/3 and negative 1/2. 5, 1/3, negative 1/2. It's this one. Oh, I can see what I did wrong. This is a positive 1. Positive 1. So that becomes a positive 5. So let's back up here. You guys probably spotted that and you're yelling at your video screen. Negative 29 plus 30 is a positive 1. 5 times 1 is positive 5. So that becomes negative 1 when I add those together. And 5 times negative 1 is negative 5. It is a remainder of 0. That's what I did wrong. Okay. So that is the correct factors, zeros. All right, here's just one on this page. Next one must be a big one. Which of the following is a polynomial with the roots negative square root of 3, square root of 3, and 2? So this gives us plenty of room to work this. So if that's the roots, then I can multiply x minus the square root of 3, or actually, since that's a negative one, x minus a negative. And then I'll do x minus the square root of 3 and x minus 2. If those 3 are the roots, then if I multiply these factors together, they would equal 0. Right? Those would all be roots. So let's multiply these together and see which one of these we end up with. So first, let's do these two. So x times x is x squared. X times negative square root of 3 is negative square root of 3x. Now let's distribute this one. So 3 square root of 3 times x is square root of 3x. The x is not underneath the radical in either one of those. See, it's coefficient. Coefficient is the square root of 3. And the square root of 3 times negative square root of 3 is minus 3. The square roots cancel each other out. That basically makes them squared. Okay, and all that will still be multiplied by x minus 2. So let's simplify this. X squared, negative 3 square root of x plus 3 square root of x cancel each other out. So we got minus 3 times x minus 2. So let's distribute x times x. X squared times x is x to the third. X squared minus 2 is 2x squared. Negative 3 times x and negative 3 times negative 2. So that should be our answer right there. X to the third minus 2x minus 3x plus 6. Perfect. We just had to multiply those back together, set them up as factors instead of roots, right? Since if that's a root, negative square root of 3 would be x. If I want it to be a factor, I just add square root of 3 to each side. Then I've got x plus the square root of 3 equals 0. That's where I got that factor from. I went backwards. I set it equal to that, moved it to the same size as the x, and that becomes the factor. All right, the next is select the graph and the description of the end behavior of f of x equals x to the third plus 2. All right, x to the third. I know what an x to the third looks like. It's a positive coefficient. That means it's going to be going down on the left side. It's going to be going up on the right side. And we're going to have a y-intercept of 2. So let's see. This has a y-intercept of 2, but it's going the wrong direction. It says the cubit phasor, decrease the right, increase the left. No. Okay, this has a y-intercept of 2, and it goes up to the right and down. So it should be this one. I think there's 2 more choices. Let's make sure none of those work. This goes down and up, but it's negative 2. That's a wrong y-intercept. This is the wrong y-intercept. So yes, this is the correct one. It has the y-intercept of 2 with that plus 2. And it goes the right direction as the end behavior. So, all right. Like those quick and easy ones, right? What are the coordinates of the turning point for the function f of x equals x minus 1 to the third minus 3? Well, to get the x coordinate, you set this equal to 0. So add 1, x equals 1. So that's the x part. And if you put 1 in there, 1 minus 1 is 0. So negative 3 is the y. That's the turning point. Kind of works like the vertex does. Very similar to vertex form. 1, negative 3, right there. Very similar to vertex in quadratics. All right. What is the end behavior of the function negative x to the third, blah, 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 blah? I don't care. All I need to know is the largest coefficient. It's to the third power. It's negative. See, normally the third power goes down and up, but since this is negative, it's going to change. It's going to go up on the left side and down the right side. In between here, it's going to curve around and do whatever, but the end behavior means up on the left and down on the right because it's an odd function, odd number, up, down, because it's negative. Use the table below of the function f of x equals x to the fourth minus 2x to the third to answer this question. What's the average rate of change from x equals negative 1 to x equals 2? So when x equals negative 1 to x equals 2. All right, so how much does it change over here? This changes positive 3, right? Because if we set it up as a slope, because that's all we're looking at, slope between 2 points, this goes from 3 to 0, so that goes down 3. So the average rate of change is negative 3 divided by 3, negative 1. Just make it a straight line between those 2 points. See, that one goes down 3. Okay, use the following graph to answer this question. Here's the function. What's the average rate of change from x equals 0 to x equals 1? Okay, well, let's see. When x equals 0, we're right here. When x equals 1, we're right here. And when we draw a line, what's the slope of that line? The rise is 0. So it doesn't matter what the run is. 0 over anything is 0. Slope is 0. Doesn't matter what it does in between there. I just want to know from this point to this point, what's the average rate of change? It's another word for slope. It's another word for slope. All right. Use the following graph of the function f2x to the third plus x squared minus 3x plus 1 to answer this. Average rate of change again. All right, from x equals negative 2. So at negative 2, looks like it's down here at negative 4. And at x equals 0, it's right there. So I want to know what is the slope or average rate of change of that line right there. the slope? Rise over run. 1, 2, 3, 4, 5. 1, 2. Average rate of change. Unless it's supposed to be here. It looks like it's supposed to be here because 5 over 2, 1, 2, 3, 4, 5, 1, 2 is not one of the options. It's kind of hard to tell from the graph. It must be, this must be the point. 1, 2, 3, 4, 5, 6 over 2 is 3. So our line's actually going down to that point. It's not the red one, it's the one beneath it. Could have been either one there, but since we didn't even have the choice of 5 over 2, we have to assume it must be down here at 6 over 2. Slope of 3. All right, approximate the real number solutions to this polynomial function. Okay, so we know, again, the coefficient's 1, and that's all it can be. Over here, it can be 1, 2, 3, or 6, and it can be positive or negative, any one of those, right? Plus or minus. How many positive ones can there be? Starts with a positive, goes to a negative. There's one sign change. Negative to a positive, 2 signs. So the positive is 2 or 0. That's what Descartes' rule tells us. Negative, if we substitute negative x in there and take it to the third power, that's going to be a negative. If we substitute a negative in for x squared, negative x squared is going to be a positive again. So it's still going to be negative 4 times a positive. That's going to be a negative. That's going to change to a negative because x, substitute negative x in, that's going to be negative x, and then a positive. So that means there is one negative root. So there's 3 roots altogether because this is next to the third. And we know one of them for sure is negative. One of them is negative. This has 2 negative ones. We can rule that out. 1 negative, 1 negative. That has 2 negative. We can rule that out. So it can only be this one or this one. So let's just do some synthetic division again. So x equals, both of them have 3. So let's use 1 and negative 1 as the difference. Let's try 1. This is 1x to the third minus 4x squared plus 1x plus 6. All right, bring this down. 1 times 1 is 1. Add those together. Negative 3 times 1 and negative 3. Add those together. Negative 2. Negative 2 is 4. 1 is not, it appears. Let's try negative 1. 1, negative 4, 1, and 6. 1 times negative 1 is negative 1, so that's negative 5. Negative 1 times negative 5 is 5. 5 plus 1 is 6. Negative 1 times 6 is negative 6. Remainder of 0, negative 1 is one of the roots. So we're going to go with that answer by process of elimination. Process of elimination. We can always graph it if we want to verify it, but we're gonna go with our gut there that we mathematically eliminated all the other answers. All right, another graphing one. Which of the following graph represents the function x to the third minus x squared minus 10x minus 8? So we know the y-intercept, because all these put 0 in for x, those all go away. We know x to the third is going to go down and up on the ends. Down on the left, up on the right. So let's look. This goes down on the left. They didn't give us the whole graph, but it would connect and go up on the right. And it looks like negative 8. This may be the one. This has a positive 8 y-intercept. It can't be that one. Let's see what we have over here. This has a positive 8. Can't be that one. This has a negative 8. But look, this goes up, down, up, and down again. This is a 4th degree. Negative x to the 4th degree. That is not the one we're looking for. So we wanted this very first choice. It goes down, up, up, down, up. In behaviors. Those are important to know. Since this is a positive x to the third, it could be down on the left side, up on the right side. Important to know that your open response part has asked you about in behaviors, so you need to know what to say. Which of the following graphs represent the function of this? Here's another one that's x to the third. It's a positive. So again, it's going to be this, and the right end's going to do that, and we have a y-intercept of 1. There's a y-intercept of 1, but this is going up on the left. Ours goes down. This is, again, This is an even. This is like a 4th degree or 6th degree or something. This one, down on the left, up on the right with a square root of 1. It should be this one. I think there's one more choice we can look at. Oh, yeah, that's an even number one. That's not an odd numbered graph. So this is the one we're looking for. All right, we're almost done here. Given the parent function of f of x equals x to the 4th, we know x to the 4th would look like that, except this is a negative one. That's upside down. What change will occur when the function is changed to negative f of 2 of x? Okay, so it would become a negative because it's outside, and when we substitute 2x into it, 2x to the 4th comes negative 2 times 2 times 2 times 2 is 16x to the 4th. So comparing negative 16x to the 4th to x to the 4th, first of all, it's going to turn upside down like this one. So the graph's going to open the opposite way because this is a positive. It's going to open up. So it's one of these two. And is it wider or narrower? Well, that 16 multiplied by there is going to make it much narrower because instead of a number being right here, it's going to move way down and be 16 times that. So it's going to be narrower and open the opposite way. If this was less than 1, if this was a fraction, 0.5 or something, that would make it wider. Okay, given the parent function of f of x equals x to the 3rd, what happens when we do x plus 3? Remember, when it's inside with that, if there's a plus, that's going to make it move left. That's just the opposite of what you think, right? If it's x minus, it would move right. But since it's inside, it's going to shift left 3 units. Okay, here's another one. Use the graph to answer this question. Okay, given the parent function, x to the 3rd, okay, this looks like a third. What is the value of h in the translated graph of f of x minus h plus k? See, the turning point on x to the 3rd is right here at 0, 0. This turning point is over at 3, 2. 3, 2. See, it's over and up. So that means this would be x minus 3 plus 2. The k would be 2. The h would be 3. So we want 3. If this was a negative, then we would choose positive. This would be a positive right there. So it would say x plus h if that was a negative, but it's not. This is a positive, so the minus fits perfectly. And we want h equals 3. Okay, which polynomial identity should be proved that 35 equals 8 plus 27? Well, 8 is, I notice, 2 to the 3rd power plus 3 to the 3rd power. This is 2 to the 3rd power plus 3 to the 3rd power, so that is the sum of cubes. And we can use that pattern they gave us. Remember, there's a pattern you use with that where you have a plus b, 2 plus 3, times a squared, which is 4, minus ab, which would be minus 6, plus b squared, plus 9. So this would be 5 times 13 minus 6. See if we can figure that out and say it's 35. Using that pattern between a plus b when they're both cubes. But all we need to know is the rule here, saying what identity. It's the sum of cubes because this is adding two numbers that are cubes. Hey, last problem. We've been looking for the last problem. Oh, another one. Which polynomial identity? 117 equals 125 minus 8. Will this be difference of squares? It's a difference. Is 125 a square? Is 8 a square? No, neither one of those are squares. But 125 is 5 to the 3rd power, and 8 is 2 to the 3rd power. And this is a difference. Difference of cubes. That's it. That is it. We have expounded all of our mathematical energy for today, and we are done with the practice tests. If you have questions on that, let me know. Get with me before you take the test. Make sure you understand, and I will talk to you next time.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.